All right, everybody. I'm back up online here. Going to make another video, and it's going to be about remote ID again. And you're probably thinking, why this again? Well, I'm continuing to try and improve the capabilities in the WarDragon. And while I was already able to detect and decode the Bluetooth type remote ID, really wanted to kind of add for those rare instances where there is the Wi-Fi type remote ID. And so that brings me to this video here and this repository that is open on my screen on a WarDragon here. The same individual that did the Sniffle fork has done this particular project after just some discussions and pointing out to the individual, hey, there was some other projects out there that used different techniques to detect and decode the Wi-Fi. Well, this is now all kind of combined into one project here. Still uses Sniffle, but it also has a Wi-Fi capability. And there's some differences here, and I'm doing this video to point it out because the videos that I've done in the past, they'll still apply if you use the directories that already exist in the WarDragon. But there's been some changes to the fork of Sniffle. So Sniffle no longer does the when you run that sniff receiver, you may remember me using in previous videos, it no longer does the detection and decoding and the ZMQ all in one. Okay, this has been broken out to where you can have multiple things feeding, and I'll show you what I mean here in a second, but just envision you have your Wi-Fi program running detecting, and you have your Bluetooth program running and detecting. Okay, those are going to be ZMQ servers that another what would I say, overarching decoder is going to be able to connect to those different feeds, take the information in, decode, and then offer up a ZMQ server with a one output out, one port number out that we'll be able to connect to get those decodings. So it's kind of like a multi-level thing here, but this gets better, and I'm trying to think of ways to maybe have services running on the WarDragon where at least maybe, for example, the decoder could just be running in a service, so that way when you start up your things that are going to feed the decoder, at least part of it's already running. I don't know, I got to think about it a little bit more, but let me do a refresh on here because I just was actually doing this video and ran across a couple just minor issues. I don't see that it's been updated yet, but I'm sure by the time you watch this video, some of the things that I are going to correct we won't have to do. But first, I'm going to go into the WarDragon directory. You can do it in any directory you want, but this, I have some projects included in here post install on the WarDragon, and I'm going to do a git clone of this DroneID. Now, don't get actually, let me remove, because I was messing with this a little bit ago, and we'll just take it from the top. So we're going to git clone that down. Okay. Now don't get confused because it does say DroneID, and I've done other videos on DJI DroneID, and that's kind of something different. So don't let that name confuse you. You also see Open DroneID over here. That may get a little confusing, but what I'm trying to go after is the ability to detect and decode the FAA remote ID latest specification. I can't even remember what it is. I'll try and remember to put it in the description. But that's what I'm referring to, and that remote ID that's used in other areas, it may be referred to something else in Europe, but this should detect and decode there as well. Okay, so let's change into our DroneID directory. Oop. Let's see, control, and we're going to take a look. We're going to look at the setup.sh. I'll make this a little bit bigger. I'm going to do this manually, okay? So this really applies to getting kind of set up for what's needed for the Wi-Fi type. And I'm thinking about maybe a different way of doing this. But for now, we're going to do a virtual environment, and I'll keep it just like it shows here. I added the Python 3. That's going to create that hidden directory. If you get a complaint if you're just doing this on Dragon OS, Focal X, and not on the WarDragon, you might have to install additional a package to make the VENV. And then we're going to source that and activate it. And then we're going to use this here on the Python that's installed in the VENV. These two different set cap attributes, I guess you'd say, are important for dealing with these packets at a very low level and what's actually happening behind the scenes. So you gotta run that right now. And let's see, we'll just do a pip3 install of the requirements here, which I could probably do these system wide, but and now if we look at the enable monitor mode, I did it a little bit differently. Let's see, I'll come back and I'll look at, oh, that's another thing before I forget. So we get cloned down that DroneID, but we need to initialize that submodule Sniffle, and we'll update it. So we've got that. And I'm going to look back here at my history somewhere here. Because I already have the interface in monitor mode on the WarDragon internally. I did an IW config and I saw that there is the WLP2S0, so I used IW and turned power save off, which actually may not even be necessary. And then I used the IW command again, particularly the PHY, and said, hey, the PHY 0 interface, because there's only one in there, add an interface called mon0 of type monitor mode, and then I brought that up with a sudo ifconfig mon0 up. You can see it here. So we've got an interface that is in monitor mode. And let's see, let's look at our Wi-Fi receiver. Actually, I'm going to look at the contents of it, and this will make a little more sense if you see what I'm talking about here, the way this works. So these are some of the arguments that we can pass, and you'll see how there is the -z, which we're going to use to do ZMQ, and --ZMQ setting. Okay, that ZMQ setting, that's saying, hey, run on localhost and offer up the information on port 4223. The interface, ignore that. That should be referring to the wireless interface, and then debug. You'll see there's needs to be a little change in this right now, so it's gonna, you'll see what I mean. So we're gonna leave it let's see, so Wi-Fi receiver, let's look at it again. We're gonna take -z. I'm gonna leave the ZMQ --ZMQ setting. I'm just gonna leave it default is fine, and we'll do a -interface of mon0, and then we'll do --debug. But because there's something weird going on there, you should just have to do --debug. Shouldn't have to stick true on there, but I'm just doing it just because under the circumstances there's a little bit of a bug. So now we're running the sniffer on interface of mon0. Now I'm going to have to spoof some Wi-Fi packets, but I have checked this repository against the DJI Air 3 that had a firmware update and was doing the remote ID of the Wi-Fi type. So let me do one more refresh here. Oh yeah, see, we got an update here 3 minutes ago. So some of the things that I pass along, he's updated. So let's stop this, and we'll do a, let's see, we'll do a get pool. Okay, so, and we'll see that might get rid of that bug. Let's try it without debug. Okay, so still that's not addressed, but the other thing that I saw maybe is addressed. So okay, so we've got that running, and now let's see. Now let's go back in, and we're going to set up our Bluetooth type receiver like we've done before. If we look at the Bluetooth receiver, we can see that it is going in and starting up the sniff receiver in the Sniffle directory. I'm just going to do it manually for now. Sniffle Python CLI sniff _receiver. Oh, you know what? Let me show you this too. and you'll understand the change now from the previous videos I've done. We look at its arguments somewhere here. We look at its arguments and we see that now there is the dash dash ZMQ setting, and it's on a default of 4222. So we got this is going to serve up the detections on 4222. Okay, this one was 4223. So let's go ahead and Python 3. Let's see, I meant to do, let's do dash L dash, you can do E and A, long range extended, and we'll just do passive, and we're going to do a dash Z. And so now we should be looking for Bluetooth information. I'm going to minimize this, and now we'll open our other window here, and you'll see what I mean now. So let's see, so DroneID, and we'll cat out our ZMQ decoder so you can see what I'm saying here. So now we can see we're going to do a dash Z, we'll do a dash debug ZMQ setting. Okay, so now we're going to offer up, and you could change this if you wanted to say put 0000 to be able to reach the WarDragon remotely and subscribe to this feed. Okay, but that's on 4224, and we can see we're going to listen to the two clients, the 4222 and the 4223, to feed into this decoder. Let's see, ZMQ, and we want to do dash Z. We'll try the debug and see if that's fixed. Let's see, and we'll find out here real quick. Let's see if that's fixed. Let me do a, I'm going to turn on a Bluetooth transmitter here real quick. Yeah, let's see, so we need to fix something here real quick. And we can see that I did get a Wi-Fi type because my transmitter must still be on. Let's see, let me share this here. So we need to try and fix this real quick here. We're going to come down here. We're going to initialize. Let's see, we're going to, I think. So I'm kind of doing this on the fly here. Let's see. Let's try this. I'm going to turn my transmitter back on. There we go. Okay. So now I'm going to stop it for a second. So I'm not going to run this long enough to where it gives GPS location. But now I hope that's making more sense. So in this case, we've got our one program set up that's waiting to detect the Bluetooth remote ID. Okay. And then our decoder is subscribed to it and decoding. And it's also offering up over ZMQs. So I could, and now this script needs a little bit of work for the Wi-Fi type, I believe, but we can do our WarDragon. Aha, there we go. So there we've got a spoof of Wi-Fi type, and we can see that it decoded it over here, open DroneID Wi-Fi, and it's got quite a bit more information in how it's decoding. Let me take a look at this here. We can see it is working. Do this real quick. Just sharing this. Okay, sorry. So now we've got a decoding of, and I'm kind of comparing the differences here in Wi-Fi versus the Bluetooth decoding. But let's take a look at Sniffle to TAC, and we'll do. Let's see, we need to do the ZMQ host and port, okay? And we're going to change this because we're going to do dash dash ZMQ dash host 127.1, and we'll do dash dash ZMQ dash port 4224, and we should see, you see, we got a subscriber for here. Now, I kind of expect that the Bluetooth will probably come through, decode, and be over here fine, which actually, yeah, there we go. Let me stop that for a second and do a dash D for debug. Let me start it up again. So it looks like it's going to be, I'll try it some more. It looks like it'll be okay coming through into the Sniffle to TAC. And I'm going to stop it for a second and we'll see if we get one of the Bluetooth type, which I think I might need to work on because it looks like there's a little bit of a difference there. Let it run for a little bit more and see if we get a Wi-Fi type. But hopefully you see where this is going. I know that I've got multiple windows open here, but what I want to do is set up some of these as like a service or something that's just running in the case of the WarDragon, considering at least the Sniffle dongle is dedicated to DroneID detection. Although Sniffle does many other things, and you could stop, for example, stop the service and use it for something else. Bluetooth, just generically Bluetooth related. But I'm gonna see if I can get one more Wi-Fi packet here. It's kind of funny, the spoofer that I'm using. It's just kind of, let's see. Let's see if we can get one more here. Okay, so we did get another Wi-Fi type in and through Open DroneID Wi-Fi. Okay, and so let's see. We got error receive process string receive. So I'm gonna have to probably have to work on this a little bit here and see receive JSON. Yeah, well, I'll have to just look a little closer at the Sniffle to TAC thing here and see if I can account. Maybe there's some differences you can see in how the Open Drone ID Wi-Fi is broken out versus the Bluetooth 4.5. I know it looks a little shorter because it doesn't have GPS location in it, whereas this has got some spoofed location information in it. So, all right. Well, hopefully you hung into the end there. Try this out on your end. Provide some, feedback, whether it's in the comments or over on the project itself. But what I want to do is start including this in the WarDragon and just keep refining it. Now, like I said, the old method of the kind of the all-in-one Sniffle drone, I think it is, whatever directory, I'll still, yeah, Sniffle underscore drone that I've shown in previous videos. Just keep in mind that if you try and follow along my videos and you're using maybe the latest Sniffle fork, that there is some differences there, and for it to work, you're either going to need to pull maybe an old build or something, where it still had the decoding and everything all in one, or remember that there's this DroneID project that you probably would want to grab if you want to use the new technique. All right. So there we go. Thanks for watching, and hopefully this is of interest and helpful. All right. Thanks.